Given three numbers in a least numbers continued proportion, a to b to c, we'll show that any two added together is relatively prime to the third. Proposition 8.2 says a and c are square, and that we can write a to b to c as d squared to de to e squared. Being least numbers, d squared and e squared are relatively prime, so d and e are relatively prime. The sum of two relatively prime numbers is relatively prime to the summands, so d plus e is relatively prime to both d and e. D plus E and D are both relatively prime to E, and the product of two relatively prime numbers are relatively prime to the third, so D plus E times D and E are relatively prime. Or D squared plus DE and E are relatively prime. Or D squared plus DE and E squared is relatively prime. Therefore, A plus B and C are relatively prime. We can show in the same way that b plus c and a are relatively prime. Now, d plus e is relatively prime to d and e, and d plus e squared and de are relatively prime by proposition 7.24 and 25. Or d squared plus 2de plus e squared and de are relatively prime. Or d squared plus e squared and de are relatively prime. That last logical jump comes from the idea that if x minus y and y are not prime to each other, x and y are also not relatively prime to each other, because we're only changing x by a factor equal to y. So, d squared plus e squared and de are relatively prime means a plus c and b are relatively prime.